module 3. Okay, in this module 3 we have the discussing into functional several variables, mean value theorems. Functional several variables, mean value theorem. Okay, so in this we have the discussing continuous functions, next differentiability, derivable. Okay, those conditions will be discussing in the module. And next one, mean value theorems. Mean value theorems. Okay, here yes, in this you learn Rolle's theorem, next Lagrange's mean value theorem, Lagrange's mean value theorem, next Cauchy's mean value theorem, Cauchy's mean value theorem. Okay, the Rolle's theorem and Lagrange's theorem both are the single function. This both are, we have the discussing single functions. Okay, next is a two functions. Okay, so sorry. In this, we have the functional several variables and mean value theorem in the continuous function. If you have this, any function is said to be continuous, we can they have the satisfying to the function f of x is the continuous. The at the point of we have the writing to limit x tends to a minus f of x is equal to limit x tends to a plus f of x. These conditions will be satisfied, and that point they have the function is continuous. Okay, if you have the in the simple words, you can say into that in the curve. If any curve we cannot breaking, or any disturbing on the curve, so that is called as a discontinuity of the curves. Or we have the continuous, never end of the value curves. Okay, if any place of we cannot stop and we cannot break. Okay, that type of curves will be called as a continuous curves, like sine curve, cos curve, tan curve in between to the minus pi by 2 plus pi by 2. In these points only they have the continuous. The remaining 0 to pi we cannot say into that is a discontinuity of the functions. The reciprocals also they have the writing the same functions of trigonometric functions. Inverse trigonometric functions also same, sine inverse, cos inverse, tan inverse. Okay, and cot inverse, those are also we have the continuous. The tan and cot they have some condition is the minus 0 to 1 and minus 1 to minus plus 1 or minus infinity to plus infinity. In this between only have there are the continuous. And polynomials also we have the continuous functions. They have the like x square, 1 by x square, 1 plus x square plus 1. So those conditions are, we have the curves will be, they have the as a increasing or decreasing. They have the continuous functions 1 by x square existing the value. The remaining points only we can, they have the continuous functions except 0. we have the remaining points will be considered, they have the continuous function 1 by x square. Like those problems are already you have the discussing in this continuous functions and derivable functions. Okay, so next mean value theorems. Okay, mean value theorems. Mean value theorems, here we have the discussing the three types of theorems we learn. The first one is the Rolle's theorem, and second one is the Lagrange's mean value theorem, and third one is Catcher's mean value theorem. Okay, what is the Rolle's theorem is nothing but
సార్ వాయిస్ బ్రేక్ అవుతుంది సార్ మళ్ళీ.
the inconvenience. Okay, so here we have the discussing into the Rolle's theorem. Yes, in the Rolle's theorem we have discussing the first one is the f of x is a satisfying to the Rolle's theorem. They satisfying to the three conditions. The first condition is it is continuous. It is continuous in closed interval of a comma b. Closed interval of a comma b. And the second condition, it is derivable. Derivable in open interval of a comma b. And the third condition is we have the satisfying to the f of a is equal to f of b. These conditions are satisfied. If anyone is not satisfied, we cannot satisfy into the Rolle's theorem. These three conditions are satisfied. There exist at least one point, C belongs to open interval of a comma b. C belongs to open interval of a comma b. That is, we have the writing to f such that we can writing to the finding to that equation, that point, we can writing to the f dash of c is equal to 0. So these conditions will be under the Rolle's theorem. Next, the second condition of second theorem is Lagrange's mean value theorem. Okay, mean value theorem. Yeah, so in this they have the satisfying to the f of x is said to be Lagrange's mean value theorem. It is continuous. It is continuous function. It is a continuous function in the closed interval of a comma b. And second one is it is derivable. It is derivable in open interval of a comma b. In a open interval of a comma b. Here the third condition is not there. We can not writing. So because of here f of a is not equal to f of b. Okay, so we cannot require for that. So these two conditions are satisfied. It is a continuous function in the closed interval of a comma b, and it is derivable in open interval of a comma b. These two conditions are satisfied. That function is satisfying to the Lagrange's mean value theorem. There existing at least one point C belongs to in a open interval of a comma b, and such that you can writing to f dash of c. F dash of c is equal to, we can writing to f of b minus f of a by b minus a. This is called as the Lagrange's mean value theorem. So in this, they have both having the geometrical interpretation of the values. If f of y is equal to f of x is a continuous curve. It is a continuous curve. It is a continuous curve. We can take into the maximum points. Okay, so in this and the lower bounded values and maximum points of values we can take into that. They having to the in a curve is a continuous curve. So is a y is equal to f of x. F of x is a continuous curve. We can take into the some points in between to the a and in curve of b is the b point. So is a f of b and this point is have the represented by the f of a. Okay, f of a is a maximum point. If it has a maximum or upper bounded or lower bounded of maximum points will be taking to the here in this curve. This is a some tangent point. The tangent point and is the maximum point. We have the taking to that is a tangent point. Only single point and they having to the in between to the f of a and f of b, or we have right into the a and b in between to there. They have the tangent of curve and the tangent of point is writing to c comma f of c comma f of c. They having to the parallel to x axis, the parallel to the x axis. So this is called as a geometrical representation of the Rolle's theorem. The same like we have the taking to the Lagrange's mean value theorem. Here we have the some curve. We have the continuous curve. V in between to the is a curve a and B. This is a curve. We have the tangent. The tangent is parallel to the curve. The parallel to the this curve will be parallel to their tangent point. So this is called as a we have the slope of the curve. The slope of the curve is writing to f dash of c. F dash of c is equal to f of b minus in the y axis. In the difference between the distances f of b minus f of a by and the x-axis b minus a. So if you are the taking to the this points of a and this point of b, and you can write into the f of a and this is have the taking to as f of b. So their distance in between to them, we have the slope of the curve is f dash of c is equal to f of b minus f of a by b minus a. This is the geometrical interpretation of the Rolle's theorem and Lagrange's mean value theorem. So next you can take into the next theorem is Cauchy's mean value theorem. Cauchy mean value theorem. Here they have taken to the two functions. They have taken to the two functions. The two functions are we have the continuous functions. Cauchy. Third one. Cauchy mean value theorem. Cauchy mean value theorem. The first statement is f of x and g of x. F of x and g of x are the functions. They satisfying to the Cauchy's mean value theorem. They satisfying to that the first condition f of x comma g of x are continuous functions or the continuous functions in closed interval of a comma b and the second point is f dash of x and g dash of x are derivable open interval of a comma b. And the third condition, g dash of x g dash of x is not equal to 0, x such that x is belongs to in open interval of a comma b. These three conditions are satisfied. They have the two functions will be called as the catcher's mean value theorem is satisfied. So they're existing into the in your x is belongs to an open interval of a comma b, then we can write into f dash of c by g dash of c. G dash of c is equal to f of b minus f of a by g of b minus g of a. So this condition will be satisfying to their, they have the, that is called as a catcher's mean value theorem. Okay, if anyone has the doubts. Hello.
No, sir.
Hello.
No, sir.
Anybody? Okay. This is the your topics, ma. In your in the first CI one, they having to raskuntara idi. Anybody?
No, sir.
రాసు
No, sir.
రాసే వాళ్ళు రాస్తా అంటే రాయండి, లేదు సార్ అంటే నేను తీసేస్తాను మరి.
స్క్రీన్ షాట్ కొట్టుకున్నాం సార్.
ఓకే. ఓకే తీసేస్తున్నానన్నా. యా, బ్యాక్ టు ఫ్రంట్ వెళ్ళిపోదాము. సరే, మాడ్యూల్ 1 చేశారా మీరు? మాడ్యూల్ 1, మాడ్యూల్ 2, ఓకే. మాడ్యూల్ 3లో ఆఫ్ పార్ట్ నాన్న. మాడ్యూల్ 3 ఫస్ట్ హాఫ్ ఓకే. ఫస్ట్ హాఫ్ అంటే మనకి ఎక్కడికి మీన్ వాల్యూ థియరమ్స్ వరకు ఉంటుంది. సో మీరు ఇంతవరకు చేశారా? చేస్తే ఏమైనా డౌట్స్ ఉన్నాయా? డౌట్స్ ఉంటే ఏం డౌట్స్ ఉన్నాయి? క్వశ్చన్ బ్యాంక్స్ షేర్ చేయమని చేస్తాను ఇప్పుడు. సో మీకు ఇప్పుడు ప్రస్తుతానికి ఏం డౌట్స్ ఉన్నాయో చెప్తే, ఏ మాడ్యూల్లో ఏమేమి డౌట్స్ ఉన్నాయో చెప్తే దాన్ని బట్టి ఆ మాడ్యూల్లోకి వెళ్ళేసి ఆ టాపిక్ మీద డిస్కస్ చేద్దాం.
ఫస్ట్ మాడ్యూల్లో హెర్మిటియన్ స్క్యూ హెర్మిటియన్ మీద ప్రాబ్లమ్ చేశారు.
అవునా?
అది దాంట్లో ఒకసారి 2 టైప్స్ ఉన్నాయి కదా సార్, దాంట్లో ఒకటి ప్రూవింగ్, ఒకటి అది ఒక్కసారి ఎక్స్ప్లెయిన్ చేస్తారు.
ఓకే. ఇంకా ఎనీవన్? ఫస్ట్ మాడ్యూల్లో ఇంకేమైనా ఉన్నాయా మీకు డౌట్స్? స్క్యూ హెర్మిటియన్ కాకుండా ఇంకేమైనా డౌట్స్ ఉన్నాయా? అది చెప్తాను ఇప్పుడు మీకు. ఎనీవన్?
గాస్ జోర్డాన్ మెథడ్ సార్.
గాస్ జోర్డాన్ మెథడా? ఓకే. ఇంకా నాన్న? సో ఆ మోడల్ మీకు అర్థం కాలేదా? హెర్మిటియన్, స్క్యూ హెర్మిటియన్.
ఎస్ సార్. ఎస్ సార్.
సరే చూద్దాం. ఎక్లాన్ ఫామ్ కూడా నానా వినలేదా మీరు? ఎక్లాన్ ఫామ్. ఓకే సరే, క్వశ్చన్ చూడండి నాన్న. ఇఫ్ క్యాపిటల్ A is equal to, if capital A is equal to 3, 7 minus 4i minus 2 plus 5y plus 5y, 7 plus 4i, 7 plus 4i, minus 2, 3 plus I, next minus 2 minus 5i, 3 minus I, and 4. Okay, and 4. Then show that A is Hermitian and A is Hermitian and IA is skew Hermitian. IA is skew Hermitian. Okay, so here we have the they have giving to the matrices. You can given matrix is capital A is equal to 3, 7 minus 4i minus 2 plus 5i, 7 plus 4i minus 2, 3 plus I minus 2 minus 5i, 3 minus I, 4. Okay, so you know that we are having to the any complex matrices you said to be Hermitian and skew Hermitian. You have the Hermitian matrix means if any complex matrix is said to be Hermitian, they have writing to the A is equal to consecutive transpose of matrix. A is equal to consecutive transpose of matrix. This condition will be satisfied. That is called as a Hermitian of the matrix. Skew Hermitian is nothing but A minus A is equal to consecutive transpose of matrix is called as a skew Hermitian matrix of the complex matrix. So is a given matrix is a complex matrix. You show that A is a Hermitian. Hermitian is nothing but they have satisfying to the A is equal to A power of theta. A power of theta is nothing but the consecutive transpose of matrix. Consecutive transpose of matrix. So we writing to the consecutive matrix. They have writing to consecutive matrix. The consecutive matrix is nothing but only complex part of sign only we can change. So 3, 7 minus 4i is there. So I is a imaginary part. Imaginary part sign is minus. Okay, coefficient is minus. So you can having to the change the coefficient plus 4i minus 2 minus 5i. Imaginary part యొక్క కోఎఫిషియంట్ మాత్రమే చేంజ్ చేస్తున్నాం నాన్న. 7 minus 4i minus 2, 3 minus I, next minus 2 plus 5i, 3 plus I, 4. Okay, there consecutive of the matrix. మనం consecutive of complex number అంటే మనం ఏం రాస్తాం నాన్న, A plus IB అంటే they can writing the consecutive matrix of complex number is A minus IB అని రాస్తామా? Okay, vice versa. A minus IB యొక్క consecutive term means A plus IB. Like we have the changes in between to this property we can use in here. And next transpose. They have the consecutive matrix transpose. So A consecutive all transpose, that is A power of theta is equal to interchanging rows into columns. So we can write into the 3, 7 minus 4i minus 2 plus 5i minus 2 plus 5i, 7 plus 4i, 7 plus 4i, and next minus 2, next 3 plus I, 3 plus I, next minus 2 minus 5i minus 5i, next 3 minus I, 4. Okay, is a power of theta. Hermitian matrix transpose of nothing but we can they have satisfying to the condition of Hermitian matrix A is equal to A power of theta. So ఒకసారి కంపేర్ చేసి చూసుకోండి ఈ మ్యాట్రిక్స్ ఉన్న గివెన్ మ్యాట్రిక్స్ ఈక్వలా ఒకసారి చూసి చెప్తారా నాకు therefore A is Hermitian. Is a Hermitian ma?
Yes, sir.
Hello.
Yes, sir.
Hmm?
Yes, sir.
So next you find that IA is a skew Hermitian. IA is skew Hermitian. So IA is skew Hermitian is nothing but A is a matrix is I is multiplying with the A. So I into A. I into A is equal to what do you get? ఏమొస్తుంది చెప్పండి మనకి ఏ మ్యాట్రిక్స్ ఏంటి నాన్న 3 7 minus 4i minus 2 plus 5i 7 plus 4i minus 2 3 plus I minus 2 minus 5i 3 minus I 4. This is multiplying with the I. So I into 3i is 3i. Next I into 7 minus 4i. We have getting to the 7i. I square is minus 1 minus into minus plus 4. Next minus 2i minus 5. Next 7i minus 4 minus into minus sorry plus into minus minus 4. Okay, next we have getting to that minus 2i. Next 3 plus I, so 3i minus 1, 3i minus 1. Next minus 2 plus 5i, minus 2i plus 5. Next 3i plus 1, 4i. అంతేనా ఒకసారి I తోటి మల్టిప్లై చేస్తే ఏదైనా వస్తుంది హలో
Yes, sir.
Sir.
Next they have the consecutive matrix. Consecutive matrix చెప్పండి అన్న దీనికి IA bar చెప్తే ఏమొస్తుంది నాన్న minus 3i. Okay, 4 minus 7i.
4. Okay.
Next
2i
2 minus I minus 7i minus 4
plus 2i
plus 2i minus
1 minus 3
3i minus 1. Okay, next 2i
2i
plus 5. Next 3 minus 3i plus 1 minus 4i minus 4i. Okay, and their transpose. So what do you get? 3i minus 3i minus 7i minus 4 2i plus 5 plus 5. Next 4 minus 7i 2i minus 3i plus 1. Next 2i minus 5 minus 3i minus 1 minus 4i minus 4i. So they transpose. They can take the common of minus in common తీయనా minus common తీస్తే minus of I a whole power of theta is equal to minus common తీసేసుకుంటే 3i 7i plus 4 minus 2i minus 5. Next 7i minus 4 2i minus 2i. Next, minus 3i plus, sorry, 3i.
Minus 1, sir.
3i minus 1. Okay. Next, minus 2i plus 5 plus minus, sorry, 3i plus 1 minus 4i, sorry, plus 4i plus 4i. ഇവ രണ്ട് ഈക്വലാ. IA is equal to minus IA whole power of theta. So therefore IA is skew Hermitian. Skew Hermitian ana? Skew Hermitian ana? Hello?
Yes, sir.
Hello? Clear?
Sir.
సమాప్రాయం అంటే తెలుసు కదా మీకు, ఎలా రాయాలో తెలుసా?
So 1/2 of a minus a transpose.
తెలుసా సమ్ రాయమంటే? దీన్ని సమ్ ఈజ్ స్క్వేర్ మ్యాట్రిక్స్. దే హ్యావ్ ద సమ్ ఆఫ్ ది హెర్మిటియన్ అండ్ స్క్యూ హెర్మిటియన్. ఎలా రాస్తాం ఇదే క్వశ్చన్ రాయమంటే?
By 2 of a plus a conjugate plus 1/2 of a minus a.
అంతేనా?
Sir.
Of capital A is equal to half of a plus a power of theta, okay, plus of a minus a power of theta. ఇదే కదా? ఇది యూజ్ చేసుకొని రాయాల్సి ఉంటుంది సమ్ ఆఫ్ అన్నప్పుడు. ఒక 10 minutes. లేదు లేదు, నెక్స్ట్ అవర్ లేదు. అయిపోయిందన్నా? ఇంకేం డౌట్ ఉంది? గాస్ జోడన్ అన్నారు కదా, అవునా?
Yes, sir.
ఓకే, తీసేస్తున్నాను. తీసేనా? హలో?
Yes, sir. Yes, sir.
ఓకే, You can see ఒక ప్రాబ్లం చెప్తాను గాస్ చూడడానికి. Okay. If capital A is equal to 4 minus 1 1 and 2 0 minus 1 and 1 minus 1 3. By Gauss-Jordan method, we find the inverse of matrix, or we can using into that, in other words, find the inverse of matrix 4 minus 1 1 2 0 minus 1 1 minus 1 3 by using elementary operations. Elementary operations అన్నా కూడా Gauss-Jordan method చేయాల్సి ఉంటుంది. Okay, don't confuse here. Here we can taking to the matrix order. What is the matrix order here? 3 by 3 matrix, the square matrix. So you can write into by using into the Gauss-Jordan method, the row operations. The row operations we can write into the capital A is equal to A into I into A. I into A. So this is the we can using into the this equation IA. So here IA is the matrix is given matrix 4 minus 1 1 2 0 minus 1 and 2 sorry 1 minus 1 3 1 minus 1 3 is the I matrix, the same order of unit matrix, the same matrix of unit matrix 1 0 0 0 1 0 and 0 0 1 into A. Okay, what we have the happening in this case, the same we can changing in the matrix also. So here row operations and column operations we can using, you can writing this matrix as a unit matrix loki marchesayali. So with the help of elementary operations, row and column operations. So here I can interchange. First I will applying to interchange. Apply is interchange R3. R1 is interchange R3. R1 is interchange R3. So what you get, we can write into 1 minus 1 3. Okay, 2 0 minus 1. Next 4 minus 1 1. లేదా మీరు కాలం కూడా ఇంటర్చేంజ్ చేసుకోవచ్చు, అదే మీ ఇష్టం. దట్ ఈస్ ఈక్వల్ టు we have the writing to 0 0 1 0 1 0 1 0 0 into A. Next apply the principal diagonal element, you keep on that one. So this is the we can keep this constant, the below the elements you can convert into zeros with the using row operation. So apply R2 is change R2 minus 2R1 next R3 change R3 minus 4R1. So what you are getting to this values is R1 you cannot change as 1 minus 1 3, so 0. So we have the minus 2 minus plus 2. Okay, next minus 1 minus 6. Minus 1 minus 6 is minus 7. 0 minus 1 plus 4 minus 3. Next 1 minus 12. 1 minus 12 is minus 11. Okay, So that is equal to first row, we cannot changes 0, 0, 1. Next 0, 0, minus 2. Next R3 minus 4 R1, 1, 0, minus 4 into capital A. Now we have the applying to the these two columns, we can convert it into zeros, these two. So can we Kaushal
+3 వస్తుందేమో కదా సార్ R3 లో
ఏమొస్తుంది?
+3 -11 వస్తుంది కదా సార్.
I cannot understand your voice. Your voice is breaking.
0 +3 -11 వస్తుంది కదా సార్.
+3 na?
ఎస్ సార్.
Okay, sorry. Applying to C2 change, C2 plus C1. Next C3 change, C3 minus 3C1 minus 3C1. You can getting to the value is 1, 0, 0 and 0, 2, 3, 0 and -7, -11. Okay, next here 0, 0, 1, 0, 0 and 1. Next you can write into C3 minus 3C1. So 1, -2, -4, -3, -7. Okay, so same like you have the applying to next row. Apply the row operation. Apply row operation is R3 change 2 R3 minus 2 R2 to R2. So you can get into the value is 1, 0, 0, 0, 2, -7, 0, 0. Okay, and next you multiplying with the this is 2 minus 22 plus 21 minus 1. Okay, next the same we can applying to that 0, 0, 1 and 0, 0, -2. Next we have the 2. Okay, next 2, 14 plus 6. 14 plus 6 ante -14 plus 6 -8. Okay, so into A. Next this element you can convert it into 0 with the help of them. So like we have the writing to the is a unit matrix. This is manaki unit matrix వచ్చేలా చేయాలి. చేస్తే మనకి ఏదైతే మ్యాట్రిక్స్ ఇక్కడ ఫామ్ అవుతుందో దాన్ని మనం ఇన్వర్స్ ఆఫ్ మ్యాట్రిక్స్ గా తీసుకుంటాం. క్లియరా? ఇంకేమైనా డౌట్ ఉందా? హలో హలో
క్లియర్ సార్.
క్లియర్ సార్.
క్లియర్ సార్.
ఓకే, ఇంకేమైనా డౌట్స్ ఉంటే రేపు మనం మాట్లాడుకుందాము. ఎస్, ఫస్ట్ మీరు నోట్ డౌన్ చేసుకొని రండి. నోట్ డౌన్ చేసుకొని వస్తే దాన్ని బట్టి మనం ఎక్స్ప్లెయిన్ చేస్తాం. ఓకే, నెక్స్ట్ క్లాస్ ఎవరినాను? సారా మేడం?
మేడం సార్.
లైబ్రరీ కాదా?
హలో
Sir,
ma'am.
no, I will take over the class, sir. Okay, sir?
Okay,
Sir, I'll continue. Okay, sir. Thank you.